Hi guys, welcome back to my channel. Hope you are all doing well. Today we are learning Vanderwaals forces of attraction among the molecule. In my previous video, I already taught about the induced dipole. So which molecules or the compounds have induced dipole? I didn't teach you how the Vanderwaals force of attraction arises in the molecule. Let's see. One force of attraction uh, is caused by the movement of the electron. The movement of the electron, V VW, one force of attraction, Wander Vanderwaals Vanderwaals force or forces of attraction are are caused caused by the movement of electrons in the molecule, in the compound, or in the molecules. Okay, now what happens when the electron move? That causes charge dispersion, and which indirectly causes a partial dipole. Look at that. So this is the molecule. That molecule, this movement of the electron causes a charge dispersion. So this end become a positive end, and that end become a negative end. That causes the uh, partial dipole in the molecule. Okay, suppose one more molecule is there. This is non-polar molecule, guys. Suppose we have one more molecule. Look at the one more molecule. That one more molecule. I have one more molecule. Look at the one more molecule. Okay, mhm, which is a non-polar molecule. If that molecule comes close to that molecule, it's just like this molecule is just like a balloon. That movement of the electron cause instantaneous dipole in that molecule. That instantaneous dipole, so it create an instantaneous dipole in that molecule. So it has a very weak partial positive and a partial negative here. Suppose this molecule is coming close together, and because of this charge distribution, this molecule oscillate, it rotate. That oscillation of the molecule causes or induce a dipole in another molecule. That induce a dipole here, induce a weak dipole. This become a negative positive, and that become a negative. So it's very weak, partial, and a partial. So one more time, guys. Look at that. Wonderful force of attraction are caused by the movement of the electron. When the electron move in the molecule, positive charge fixed at one side, that causes an instantaneous dipole or a very weak dipole. When the two molecules come close together, that molecule oscillate. So so positive end attract with the negative end, so like this. So this instantaneous dipole induce a dipole in another molecule. That's why it is called induced dipole and induced dipole. Look at that. Whether the molecule is polar or non-polar, they have induced dipole. Every molecule has induced dipole attraction. Mainly, mainly the non-polar molecule have induced dipole. Like let's see the consequences of the one volt force of attraction. Okay, so just a moment. What happens if the molecule has a one volt force of attraction? So it is caused one volt force of attraction are caused by the movement of the electron. As the number of electron increases, one volt force of attraction also increases in the molecule. Now look at the consequences of one volt force of the attraction. One volt force of attraction is directly proportional to the number of the electrons in the molecule. That electron causes a weak dipole in the molecule. Look at the weak dipole in the molecule. This is the molecule and it causes a weak dipole. So this and partial positive, partial negative. So due to the presence of one volt force of the attraction, the boiling point of the molecule increases. Now look at that question. Look at the halogens: fluorine, chlorine, bromine, and I2. So it's a past paper question. Why I2 exists in the solid form? That's the gas. That's the gas, liquid at room temperature and solid at room temperature. What's the answer? No doubt, all of them they have induced dipole. But as the number of electron increases, as the look at the size of the iodine, it's a bigger size. As the number of electron increases, the induced dipole also increases. That's why iodine exists in the solid form at the room temperature. So the answer is more one volt force of attraction for I2. Yeah, you know that. So what are the consequences of one volt force of attraction? Boiling point increases due to the presence of one volt force of attraction. The molecule has more boiling point. So let's check one more example of one volt force of attraction. Like one volt force of attraction is also called as induced dipole interaction, and it is also named as London forces. Now look at that. What happened? I will give you one more example of one volt force of attraction, which is also called induced dipole. Induced dipole. Why we are calling induced dipole? No doubt it is an instantaneous force of attraction between the molecule, but that cause induced dipole to the another molecule when the molecule oscillate. Okay, look at that. Alkene. We have alkene. Look at that. Alkenes are non-polar. We know that alkenes are non-polar. Non-polar meaning ID, induced dipole. Look at that. Alkenes, they are non-polar. When the bromine approaches, bromine is also non-polar. Bromine molecule is non-polar. When the bromine approaches this double bond, which is a pair of the electron, causes a dipole in the molecule. This causes a partial positive and a partial negative. That causes a dipole in the molecule. So this is also an example, best example of ID. I told you that all the non-polar molecules they have ID or weak intermolecular force of attraction. Let's check the strength of the intermolecular force of attraction. I have already discussed two of them, hydrogen bonding and permanent dipole. That's the third one. The last one is ID. Look at the strength of all these intermolecular force of attraction. First, hydrogen bonding. Hydrogen bonding is the strongest one because it's a type of electrostatic force of attraction. Hydrogen bonding, first one, hydrogen bonding, H bonding, and second one is permanent dipole, PD, and the third one is ID, which is also called one volt force of attraction. Now, This is the property of polar compound, and this is also the properties of polar compound. It is present when the molecules have hydrogen atom along with highly electronegative atom such as fluorine, nitrogen, and oxygen. Okay, this type of intermolecular force of reaction present in the polar compounds, and this is present in the non-polar compound. How can we check the compound is polar and non-polar? So polar and non-polar. So polar compound has PDPD and non-polar compound has Vanderwaals force of attraction of IDID. Non-polar. Polar, there is a difference in electronegativity. Electronegative value is not equals to 0. Electronegative value, difference in electronegativity is equals to 0, is not equals to 0. One more thing, the molecule is unsymmetrical, unsymmetrical, unsymmetrical. Yeah, the molecule is symmetrical. All the well-known shape of the molecules, like we have tetrahedral shape. So here examples, TD shape tetrahedral. Then we have trigonal planar, trigonal planar, and we have trigonal bipyramidal, we have octahedral OT complexes, square planar complexes, and those molecules which are polar, unsymmetrical, they should contain a lone pair of electron, like ammonia, polar 100%, water polar, and we have some such compounds which has a lone pair, symmetrical. And the dipole here, the dipole moment cannot cancel off. There will be a resultant dipole. Here, dipole moment cancel off. Look at that. We have ionic bonding, like ionic covalent. I want to compare ionic covalent, permanent dipole, dipole interaction, and one volt force of attraction, which is induced dipole, Ionic, 1,000 times greater. Ionic bonding, strong bonding, which is a very strong bonding, guys. Then we have a covalent, then we have which is greater than covalent. Then we have PDPD, sorry, then we have hydrogen bonding, which is greater than dipole interaction. Dipole meaning PDPD, permanent dipole. The lastly we have Vanderwaals force of attraction. Vanderwaals force of attraction. That's the strength. We know that. Like a very quick review: ionic between metal and non-metal, covalent between two non-metals, hydrogen is not an actual bond. Hydrogen bonding is not an actual bond. It is a type of intermolecular force of attraction between two molecules. One of the molecules should contain hydrogen atom, and the other molecule should contain either nitrogen or oxygen or fluorine. Dipole interaction, the Vanderwaals force of attraction is also a dipole interaction, but mainly dipole interaction meaning PDPD, which is present in the polar molecule, and Vanderwaals force of attraction is present in non-polar molecule. So any molecule, the weakest bond, if they will ask you what type of force of attraction is present in non-polar molecule, you can blindly say van der Waals force of attraction, which is the weakest force. So, for example, H2O, and I will give you HF. Look at the HF molecule, HF and H2O, and we have HCl, I2. Predict the type of intermolecular force of attraction. We are not talking about ionic bonding and covalent bonding. So look at the question. Predict the type of intermolecular force of attraction among all these molecules. So this is A, this is B, C, D. Hydrogen bonding, H bonding, hydrogen bonding plus, because it's polar molecule, plus PD. And I told you every molecule should have van der Waals force of attraction. So it has van der Waals force. Van der Waals. Yeah. Now come to the hydrogen. Come to the water molecule. Same thing. Hydrogen bonding. It has hydrogen bonding. H bonding, which is a stronger force of attraction when you compare to PD and van der Waals force of attraction. So it has one. What's the one? Hydrogen bonding. Yes, it has hydrogen bonding plus PD plus van der Waals force. Okay. Now HCl. HCl has. Can you guess? HCl has only PD and van der Waals. No hydrogen bonding. So HCl molecule has PD plus van der Waals force of attraction. And the last one, I told you the last one, no hydrogen bonding, obviously, no PD, non-polar molecule. It has only van der Waals force of attraction. Van der Waals force of attraction. So they will ask you such question, like they will give you ammonia and they will ask you predict the type of intermolecular force of attraction. So ammonia, let's do ammonia one, guys. Let's do one example, ammonia. Ammonia, when you come across like a compound having hydrogen and a nitrogen, definitely hydrogen bonding, like ammonia. They will ask you why the ammonia is highly soluble in water compared to the other hydrides of fifth group element. We will do the example. Why ammonia is highly soluble? Why NH3 is highly soluble in H2O. One thing, hydrogen bonding. So strong electrostatic force of attraction or intermolecular force of attraction. B, ammonia is polar, NH3 is polar. So it has PDP, permanent dipole. And lastly, each molecule has van der Waals force of attraction. C, lastly, ID, which is also called van der Waals force. Van der Waals force of attraction. Ammonia is soluble in water. Then come to pH3, ASH3, SbH3. Yeah, polar. And then which one is highly soluble? As the size increases, solubility increases. So guys, I want to stop my video here. I will come back with a different topic in my next video. Thanks for watching.